Good morning, students. Previous class we have discussed about the hyperbola, and we have derived the equation of the hyperbola to be x square by a square minus y square by b square equals to 1. And we have learnt about the conjugate hyperbola, rectangular hyperbola, etc. So, whatever the terms that we have discussed before in the chapter ellipse, what I mean is chord, focal chord, double ordinate, length of the lattice rectum, etc. will be applicable here also. So, the chord is nothing but the line joining any 2 points of the hyperbola is called a chord. So, this is the hyperbola and this is the chord. This chord is the line joining the 2 points of this hyperbola and focal chord. The chord passing through the focus of the hyperbola is called a focal chord. So, this is the hyperbola and this is the focus. Focus is the fixed point lying on the principal axis, which is the transverse axis, which is x-axis here. Okay, so this is the chord. Since this line is formed by the join of 2 points of the hyperbola and this is passing through the fixed point focus. Therefore, it is said to be focal chord. Next, double ordinate. The focal chord, the chord which is perpendicular to the transverse axis is called double ordinate. So, for this hyperbola, so this chord, unlike this chord, is perpendicular to the principal axis, which is the transverse axis. Therefore, this chord is called the double ordinate. And lattice rectum. So, the focal chord perpendicular to the transverse axis, or in other words, the double ordinate passing through the focus is called lattice rectum. So, this is our hyperbola and This is the focus and this is the second focus. Collectively, foci or foci. So, the line or the chord passing through the focus and perpendicular to the transverse axis. The chord passing through the focus and perpendicular to the transverse axis is said to be the latus rectum, or the focal chord. Focal chord means passing through the focus. The focal chord perpendicular to the transverse axis. The focal chord perpendicular to the transverse axis is also called the latus rectum. Or speaking from the double ordinate perspective. Double ordinate means the chord which is perpendicular to the transverse axis. This is the chord perpendicular to the transverse axis. So, the double ordinate which is passing through the focus is also called the latus rectum. So, we have derived the length of the latus rectum to the ellipse x square by a square plus y square by b square equals to 1 is 2b square by a. In the same way, the length of the latus rectum for the hyperbola also 2b square by a. How? Let us derive it. The length of the latus rectum to the hyperbola is 2b square by a. So the length of the latus rectum to the hyperbola, which hyperbola? X square by a square plus y square by b square equals to 1 is 2b square by a, and the extremities of the latus rectum are AE comma plus or minus b square by a. So, let us take the hyperbola. So, hyperbola is of this form. It consists of two parabolas typed. The diagram contains two parabolas, this being the center. A dash are the vertices. So this is the x-axis, which is called the transverse axis, and S dash are the foci. This is AE comma 0. This is minus AE comma 0. Corresponding to this fixed point focus, this is the fixed line called directrix. So this directrix is corresponding to this focus, and this directrix is corresponding to this focus. So this is L equals to 0, this is L dash equals to 0, and so this is the latus rectum. So let us suppose that L dash. Likewise, this is also the latus rectum. This is also the latus rectum. Let us take M dash for example. So both L dash and M dash are the length of the latus rectum. So this is 2b square by a. That means this is b square by a and this is b square by a. So totally 2b square by a. So that is what we need to prove. So here, if this is AE comma 0, this is AE comma, because C is the center, that means the origin. So from this to this AE. So this is also the x coordinate AE. So this height which I don't know, Later on, actually, we will proved this height to be b square by a. But for the time being, which we don't know the distance, the height of SL, let us take this to be, I'll take it as y. This is minus y. Since L comma L dash lie on the hyperbola, L comma L dash lie on the hyperbola x square by a square minus y square by b square equals to 1. These 2 points satisfy the equation of the hyperbola. This is the value of x is AE. So AE whole square by a square minus y square by b square equals to 1. So this is a square e square by a square minus y square by b square equals to 1. A square gets cancelled. So e square minus y square by b square equals to 1. So e square minus 1 equals to y square by b square. So by b square, if you take to this side, b square into e square minus 1. From this, y square is equals to, we know that for the hyperbola x square by a square plus minus y square by b square equals to 1, b square is equals to a square into e square minus 1. We have proved this also in the derivation of the hyperbola. So from this, e square minus 1 is b square by a square. So b square into, in the place of e square minus 1, I'll replace it with the b square by a square. So this is equals to y square is equals to b power 4 by a square. So y is equals to plus or minus square root of b power 4 by a square. Therefore, y is equals to plus or minus b square by a. So since a comma this y is plus b square by a, here AE minus y is minus b square by a. Y has got two values, b square by a minus b square by a. So in the first quadrant, this is plus b square by a, because this is positive, this is positive negative. So therefore AE comma plus or minus b square by a are the ends of the lattice rectum, and b square by a plus b square by a is 2b square by a. Length of the lattice rectum is 2b square by a. Let us write all the formulae at one place. For the hyperbola, x square by a square minus y square by b square equals to 1. The center C is equals to 0, 0. Origin is, center is at the origin. Vertex A comma A dash plus or minus A comma 0. So the hyperbola is of this form. X dash, y dash. So this is the center of the hyperbola. These are the directrices. L equals to 0, L dash equals to 0. This is B dash. A dash. So vertices are a comma 0 minus a comma 0 and foci s dash is equals to plus or minus a e comma 0. This is focus and this is the second focus. Equation of the directrices is so these two are the equation of the directrices and this is z and this is z dash. This we have seen it to be a by e comma 0 minus a by e comma 0, which we have proved in the derivation. This is minus a comma 0. This is a comma 0. This is a e comma 0. This is minus a e comma 0. So equation of the directrices is the line which is parallel to y-axis is in the form x equals to a by e minus a by e. So plus or minus a by e. Here the transverse axis is along. This is the transverse axis. So on which, what is the transverse axis? The line which is passing through the focus is called the principal axis or transverse axis here. So the transverse axis is along x-axis. So the equation of x-axis is, that is, y equals to 0 and conjugate axis is along, this is the conjugate axis, this is along y-axis. That is, equation of y-axis is x equals to 0. X equals to 0. Now, length of the latus rectum is equals to 2b square by a. 2b square by a. So, their ends are L dash AE comma plus or minus b square by a. AE comma plus or minus b square by a. Now, the length of the major axis, is, this is CA plus CA dash. So AA dash, which is equals to 2A. Length of the minor axis is BB dash, which is equals to 2B. Now, for the conjugate hyperbola, x square by a square minus y square by b square is equals to minus 1, or y square by b square minus x square by a square equals to 1. So, this parabola is like this. This is xx dash. So, a dash are here. It is not changed. A dash. So, a dash. So, here b dash. This, the focus are situated here, S dash. So, this focus corresponding directrix is this, and this focus corresponding directrix is this. So length of the major axis, length of the transverse axis is dB dash is equals to 2b. Length of the, what is transverse axis on which the y-axis, on which transverse axis means the line which is passing through the focus. So length of minor axis is a dash 2a. So transverse axis is along, so transverse axis is along y-axis. So the equation of y-axis is x equals to 0. So conjugate axis is along x-axis, that is y is equals to 0. Now vertices B dash, or this is 0 comma b, so 0 comma plus or minus b, for C or foci S dash is equals to 0 comma plus or minus b. Now equation of the directrices. So this is Z and this is Z dash, foot of the directrices. This is 0 comma plus or minus b by e. This is 0 comma plus or minus, this is plus b by e. This is minus b by e. So the line, these two are the directrices. So the fixed lines. So these two lines are parallel to x-axis. Any line which is parallel to x-axis is of the form y equals to k. So y is equals to plus or minus b by e. So here the condition is b square is equals to a square into e square minus 1. And the eccentricity E is equals to a square plus b square by a square. Here the relation between a, b and e is equals to b square is equals to a square is equals to b square into e square minus 1. So therefore the eccentricity E is equals to, which is greater here? B is greater here. Length of the transverse axis is b dash, which is 2b. So b square plus a square by b square. So these are the two ellipses whose center is at the origin. What if the equation of the hyperbolas whose center is not at the origin, shifting of the origin taken place? Then it is x minus h whole square by a square minus y minus k whole square by b square is equals to 1. So earlier the hyperbola is like this. Earlier the hyperbola is like this. For x square by a square minus y square by b square equals to 1, whose transverse axis is x-axis. So this is, earlier this C is 0, 0 here. But here origin has been shifted to some other place. So this is the origin This is the C origin, and this C dash is new origin is C dash H comma K. So earlier the hyperbola is here at C00, but now the origin is shifted to some other point which is C H comma K. So for this, the center C is equals to, earlier it is 0 0, with the x coordinate H will be added, with the K y coordinate K is added. So that's what we have learnt in the transformation of axis. C H comma K. Vertices A comma A dash. Earlier we have learnt A dash to be plus or minus A comma 0. So with the x coordinate H will be added, with the K coordinate 0, with the y coordinate 0, K would be added. Now, so here this is A dash. Next, earlier major axis, earlier transverse axis is along x-axis. Here transverse axis is parallel to earlier the transverse axis is along x-axis, y equals to 0. Here the parallel to x-axis. Earlier y equals to 0, now y equals to k. That is y equals to k. Now the conjugate axis is along y-axis. Along y-axis x equals to 0. Here parallel to y-axis. So this is y-axis. So parallel to y-axis. This is transverse axis, which is x equals to 0, and now this transverse axis is moved parallel to this x-axis. So this S dash, or this is what we have seen, H comma H plus or minus A comma K, H plus A comma K, H minus A comma K is this. Now the foci, so foci is equals to S comma S dash. S comma S dash is equals to, earlier they are plus or minus AE comma 0. This is AE comma 0, this is minus AE comma 0. Together plus or minus AE comma 0 is what we have learnt in earlier one, x square by a square minus y square by b square equals to 1. With the x coordinate H would be added, with y coordinate 0 plus k, which is k. Now length of the major axis, length of the transverse axis is 2a, and length of the conjugate axis is 2b. They are not going to be changed. So length of the transverse axis is 2a, length of the conjugate axis is 2b. Earlier distance between the foci, is S dash. This is AE, 2AE. So here also distance or length, they are not going to be changed. So it is still 2AE. And distance between the directrices. This is L equals to 0 and this is L dash equals to 0. So this is Z and this is Z dash. So CZ is A by E, CZ dash is also A by E. So 2A by E. Distance between the foci is 2AE. Distance between the directrices is 2A by E. They are not going to be changed. And length of the lattice rectum is 2b square by a is what we have seen before. Now also it is going to be unchanged, 2b square by a only. And what is the relation between a, b and e? So b square is equals to a square into e square minus 1. This is also not going to be changed. Here also e is equals to a square plus b square by a square. In ellipse it is a square minus b square by a square. But in hyperbola a square plus b square by a square. So, and x minus h whole square by a square minus y minus k whole square by b square is equals to minus 1. This earlier, so this is a dash, this is b dash, this is the hyperbola earlier, with the center being at the origin. But h comma k we could see here, that means it is subjected to the transformation of axis. Shifting of origin has been taken place. Therefore, C is shifted to some other places. That means the hyperbola is shifted to, this is the origin, and this hyperbola without actually changing the direction of the coordinate axis. So it is shifted like this. Now this is our hyperbola. X minus h whole square by a square minus y minus k whole square by b square equals to 1. So this is the coordinate axis. X dash. This is y dash. So the new coordinate axis here is a capital X dash x. This is capital Y dash. So here also center is going to be unchanged. C h comma k vertices b comma b dash is equals to 0 comma plus or minus b is what we have seen in x square by a square minus y square by b square equals to minus 1. Here with the 0 comma plus or minus b, so with the 0 h would be added, with plus or minus b k would be added. So k plus or minus b vertices, and transverse axis is earlier x square by a square minus y square by b square equals to minus 1. The transverse axis is this, which is y axis, is that is along y axis. This here along y axis means x equals to 0, but here parallel to y axis. Transverse axis is parallel to y axis, that is x equals to h. The conjugate axis is what is the conjugate axis here? This is the transverse axis and this is the conjugate axis. This conjugate axis is parallel to x-axis. Is parallel to x-axis. That is, any line which is parallel to x-axis is the form y equals to something. So y is equals to k. K is associated with y and h is associated with the x. So here conjugate axis is parallel to y-axis. That is, x equals to h here. Now, foci. So foci are S dash here. So these are S comma S dash is equals to, earlier they are 0 comma plus or minus BE. So with 0 H would be added, with BE K would be added, plus K. So next, length of the transverse axis is 2B here and length of the conjugate axis is 2A. And so here length of the lattice rectum is equals to 2B square by A. So this length L dash. So this is B square by A, this is B square by A. Here length of the lattice rectum is A square by B. Here A square is equals to B square into E square minus 1. So E is equals to square root of B square plus A square by B square. And equation of the directrices. Equation of the directrices is equals to equation of the directrices. So this as well as this here. Here the equation of the directrices are these two. What are the equation of the directrices here? Equation of directrices. Actually the equation of the directrices earlier, x square by a square minus y square by b square equals to 1 is, these are parallel to y axis. X is equals to plus or minus b by e. X equals to plus or minus b by e. But h plus or minus b by e is what we will get here. Here these two are the equation of the directrices. So equation of the directrices are earlier, that is y is equals to plus or minus b by e, because these two lines are parallel to x-axis. So y equals to something. So y is equals to this and this. This is z as z dash. So this is 0 comma minus plus b by e. This is 0 comma minus b by e. With 0 h will be added. So and with plus or minus b by e, k would be added. So this is h comma plus or minus b by e plus k. So h comma minus b by e plus k. So equation of the directrices are y is equals to plus k plus or minus b by e. So these are what we have discussed so far. So whatever that we have discussed before in the ellipse is applicable here also. The equation of the tangent at px1 y1 to the ellipse s equals to 0 is s1 equals to 0. Here also s1 equals to 0. Equation of the tangent to the hyperbola s equals to 0 is s1 equals to 0. But s1 there is xx1 by a square plus y by 1 by b square equals to 1. Here xx1 by a square minus y y1 by b square equals to 1. So tangent we know. So this is the hyperbola. So this line is a tangent. This line is a tangent to the hyperbola because this line touches the hyperbola at the unique point. So this is the tangent to the hyperbola at Px1y1, which is s1 equals to 0. So if s is x square by a square minus y square by b square minus 1 equals to 0. So the notations also same here. What is s1? Xx1 by a square minus y1 by b square minus 1 equals to 0. So s1 is this. S11 is x1, simply substituting x1 y1 point in this. So x1 square by a square minus y1 square by b square minus 1. So S12 or S21 both are equal. So this is x1 x2 by a square minus y1 y2 by b square minus 1. So these are all the notations. Now the equation of the tangent P at Px1 y1 to the hyperbola is S1 equals to 0. So equation of the tangent at Px1 y1 to the hyperbola S equals to 0 is S1 equals to 0, that is xx1 by a square minus y1 by b square minus 1 equals to 0. Now, equation of the normal. So, there a cos theta, b sin theta or the parametric point for the ellipse x square by a square plus y square by b square equals to 1. The parametric point is a p theta, a cos theta, b sin theta. But here the parametric point is a secant theta, b tan theta, because this point on substituting in this it will be satisfied, because substitute in the place of x substitute this a secant theta whole square, a square secant square theta by a square minus in the place of y substitute b tan theta, so b tan theta whole square, b square tan square theta by b square. So a square gets cancelled, b square gets cancelled. Secant square theta minus tan square theta is equals to 1. Therefore, this equation gets satisfied by substituting p theta, which is a secant theta comma b tan theta. Therefore, a secant theta b tan theta, this is said to be, therefore p theta is said to be the parametric point. A secant theta b tan theta, this is said to be parametric point. Now, what is the normal? The normal is a line which is perpendicular to the tangent and passing through the point of contact of the line and the hyperbola. So this line not only passing through the point of contact of the line and the hyperbola. So this line is not only passing through the point of contact of line and the hyperbola, but it is also perpendicular. This is also perpendicular to the tangent. Therefore, it is said to be the normal. So, equation of the normal at P x1 y1 to the hyperbola is a square x by x1 plus b square y by y1 is equals to a square plus b square. Remember, in the ellipse, it is a square x by x1 minus b square y by y1 equals to a square minus b square. Here everything we will be getting in plus only. There equation of these two are at the parametric point p x1 y1. Now at the these two are at the Cartesian point p x1 y1. At parametric point, what is the equation of the tangent and normal? Let us see this. Equation of the tangent to the hyperbola x square by a square minus y square by b square equals to 1 at the parametric point. The parametric point p theta, which is a secant theta b tan theta, is x by a, s1 equals to 0. S1 equals to 0. In the place of x1, y1, substitute simply secant theta and tan theta, because a secant theta is x1, b tan theta is y1. So x by a secant theta minus y by b tan theta equals to 1. So instead of this p x1 y1, p theta, which is a secant theta b tan theta, the equation of this tangent is this. Equation of the normal at the parametric point is ax by secant theta plus by by tan theta is equals to a square plus b square. Remember there, ax by cos theta minus by by sin theta is equals to a square minus b square earlier. Here ax by secant theta plus by by tan theta equals to a square plus b square. Now what is the equation of the tangent in the slope form to the ellipse? X square by a square plus y square by b square equals to 1. Y is equals to mx plus or minus square root of a square m square plus b square. But here in the hyperbola it is y is equals to mx plus or minus square root of a square m square, same everything, but plus b square, in the place of plus b square we will be getting minus b square. This is the slope form of the tangent, and the tangential condition is c square equals to a square m square minus b square. There in the ellipse it is c square is equals to a square m square plus b square is the only difference. The condition for the line y is equals to mx plus c to be a tangent to the hyperbola x square by a square minus y square by b square equals to 1 is c square equals to a square m square minus b square. Therefore, slope form of the tangent to the ellipse to the hyperbola x square by a square minus y square by b square equals to 1 is y is equals to mx plus or minus square root of a square m square minus b square. So this is the hyperbola. Let us suppose that this is the tangent at this point p x1 y1. So let p x1 y1 be the point of contact of the line phi is equals to mx plus c, and the hyperbola x square by a square minus y square by b square equals to 1. Just now we have seen the equation of the tangent at px1 y1 is xx1 by a square minus y1 by b square minus 1 equals to 0 is s1 equals to 0, which is this. So this is the equation of the tangent at px1 y1, which is s1 equals to 0 is this. Now, but according to this, the same line is y is equals to mx plus c. So according to this line is this xx1 by a square minus y1 by b square minus 1 equals to 0. But according to the question, the same line is y is equals to mx plus c. But according to the sum, y is equals to mx plus c is a line. So 1 and 2 represent same lines. Just now we got this line is s1 equals to 0. But according to the question, the same line is y is equals to mx plus c. So 1 and 2 represents the same lines. So this can be written as mx minus y plus c equals to 0. So let us compare the quotients. Comparing the quotients we get. So x quotient is x1 by a square by x quotient is here m. Y coefficient is minus y1 by b square by y quotient is minus 1. Here minus 1 constant by c. So x1 by m a square is equals to y1 by b square is equals to minus 1 by c. So therefore x1 is equals to minus ma square by c, y1 is equals to b square by c. So since px1 y1 lies on y is equals to mx plus c, since px1 y1 lies on this line, or y is equals to mx plus c is passing through px1 y1, both are same. Substitute y1 is equals to mx1 plus c. So we got x1 y1 here. Let us substitute. B square by c is equals to m into x1 value is minus m a square by c plus c. So b square by c is equals to minus m square a square plus c square by c. I have taken c as the LCM. So m into m square a square with minus. So c into c square by this. So c gets cancelled. So this is minus b square by c. Minus minus gets cancelled. This is minus c is this. So this is also minus b square by c. This is minus b square by c. So from this, c square is equals to this minus m square a square if you transform to this side. So a square m square minus b square. So if we want c plus or minus square root of a square m square minus b square. So therefore equation of this line in its slope is y is equals to mx plus c. In the place of c we got this. So plus or minus square root of a square m square plus b square.